Hello everyone, welcome back to the series of Database Internal. In today's video, I will talk about durability. Before going ahead with the definition, we will talk about an example of transferring money from one account to another account. So let's take same example that we have been talking in earlier videos. Alice is trying to send $50 to Zon. This is the account table. It has ID column, balance and name. And this is the query. So we start the query with begin transaction and we are committing the transaction. Between this, there are three main queries. I have annotated the query with this orange annotation. Basically, query one is nothing but a select query. We can call it a read query where we are trying to initialize the sender balance so that we can check if sender has enough amount or not. Query two is nothing but deducting that amount from sender balance. And then query three is crediting that money to John's account, right? So I have annotated all three queries. Now, whenever I say query one, query two, query three, I'm just referring to these three queries. So basically, query one is a read query two is a write query, and query three again is the write query. Now, in this example, I will talk about all the failure scenarios where database server might go down, right? Or system might crash. There might be a power outage or any other kind of failures. The disk might get corrupted, or there is something wrong with the system itself, or system restarted. So there are n number of possibility that can go wrong even after the transaction gets successful. Let's talk about case one where everything went well, nothing goes wrong, and then we will understand what can go wrong. So there can be n number of possibility, but we will talk about two or three possibility, and then you will get an idea of what exactly we are trying to convey over here. So in case one, we will basically understand what all components are there and what, when we say everything went well, what is going well. So as I already have annotated one, two, and three, these three query, read and two write queries. Suppose we are trying to execute this query. So basically this query will be executed through a client. This client can be anything, right? A software, application server, or database UI, or any other software which calls this database server internally. Now there will be a system where this database server will be installed. The system will have a CPU, RAM, SSD, HDD. Database server is again a software, right? Now what it will do is it will accept this query sent through the client, or you can say some other software or application. Database server will accept that query and process it on CPU. After every query, it will try to cache it in RAM, something called as IO buffer. For now, just remember there is something called as IO buffer on the RAM. It just try to write all the write statements in that IO buffer, and then it will flush the write operation on the disk. So once the transaction is committed, basically all three query has been executed and transaction is committed. In that case, data will be written to permanent storage so that we do not lose our data. We will come to the scenario where the disk itself might get corrupted, right? Or system might fail badly, or we can't recover the disk itself. In obviously in that case, we will keep replica of those data on some other server. There are other strategies as well, but I'll try to keep it in context of durability only, in context of database transactions. But yeah, we can keep multiple replica of those data and keep syncing the data. But right now, let's go case by case. So in case one, everything went well and we understand a basic architecture or components, what database server does. Now let's come to the case two. Case two says after successful execution of two queries, third query failed because of power failure. So when I say power failure, so this system, so basically this is representing a system. This whole box is representing a system. Obviously there will be a power input to the system. Assume transaction started and query one is successful, query two is successful, but query three failed. So basically we have initialized the sender balance. We have deducted the amount, written $650. So if you can see Alice balance, it is $650. Earlier it was $700. But query three failed. What was query three? John should have received that $50. The balance of the John should be $150. But query three failed, right? Now database has to roll back. What rollback the database will do is it will again roll back the Alice balance to 700. Otherwise, what will happen is amount has been deducted from Alice account, but has never been credited to John's account. But let's assume a scenario where these two query get succeeded, and when third query was executing, the system crashed. Obviously, the transaction has not been committed, and even after the commit of transaction, database might take some time to flush everything from IO buffer to hard disk. Since only two query got succeeded, and while query three was executing, system crashed. Now it's database responsibility whenever this system comes up to roll back all the successful write operation, because this transaction was partially committed. If a transaction is partially committed, we will roll back all the write operation made by that transaction. So even in case of failure of the system where database server is installed, it's database responsibility, and database guarantees that in case of partial commit, I'll roll back all the write operations. Now let's come to the case 3. Just after successful commit, system went down. Here you can see query 1 succeeded, query 2 succeeded, query 3 succeeded. But just after committing the transaction and just before it made those write permanent by flushing it to the disk, the system crashed down. Now client got the response that all the query has been executed successfully. Now whenever database comes up, it's database responsibility that once a transaction was completed, committed transaction, it should not roll back, right? Here it should be $150. Once transaction is committed, even in case of power failure, system crash, whenever this server comes up, database will permanently write those operation on the disk. Now let's come back to the definition. Durability is one of the 4 key properties of database transaction in the ACID model: atomicity, consistency, isolation, and durability. Durability ensures that once a transaction has been committed, its effects are permanently recorded in the database. Even in the event of system failure, such as crash or power outage, it can be any kind of failure. Now you must be connecting the dot. So basically, database guarantees that once a transaction has been committed, it is written permanently on the disk. So what durability ensures? Durability ensures basically 3 things: recovery, persistence, and data integrity. So recovery is nothing but even if a failure occurs after a transaction is committed, just before the changes are fully written to permanent storage, the database system has mechanism to recover those changes. How does it does that? There are multiple ways it can do that. In the next video, we will talk about how does database maintains durability and atomicity even in case of system failure. So internally, database maintains something called as write ahead logging. It's a way to log all the transactions going in the database. So basically, it logs everything. I'll come to that video about the write ahead logging and explain in very detailed way. Now, persistence. Once a transaction is successfully completed, the changes are stored in a way that they will not be lost, even if the system restarts or encounters error. We have seen that, right? Data integrity. Durability helps maintain the integrity of the database by ensuring that completed transactions are never rolled back or lost due to system issues, right? Basically, we have seen all those cases. In next video, we will learn about what is write ahead logging and how database guarantees durability. Even we will see how database guarantees atomicity. So we will exactly see the internal implementation of atomicity and durability so that database guarantees, okay, this transaction is atomic, this transaction is durable, and different databases has different implementations. In next video, we will talk about write ahead log. So stay tuned for the next video. Please do not forget to subscribe and press the bell icon. That's all for this video. Thanks.